children, I am Ekta. Imagine you are stargazing on a circle night and you notice the moon shining brightly in the sky. The moon shape and the wheels of a bicycle remind you of a special geometric figure, the circle. In this lesson, we will explore the world of circles, understand their terminology, and uncover essential theorems related to them. Let's embark on a celestial journey into the realm of circles. In this lesson, we will delve into the captivating world of circles. We will discover their unique terminologies such as radius, diameter, chord, and circumference. We will also explore significant theorems including the Pythagorean theorem, the inscribed angle theorem, and the tangent chord theorem. By the end of the lesson, you will have a deep understanding of circles and their fascinating properties. Learning outcomes. At the end of this lesson, you will be able to understand the basic components of a circle and its related terms. Identify and apply the theorems related to chords, tangents, and angles in a circle. Recognize the properties of cyclic quadrilaterals and their angles. Calculate distances and length of chords in relation to the center of a circle. Apply the concept of the circle through 3 points and its circumcircle. Keywords: circles, radius, diameter, chord, circumference, Pythagorean theorem, inscribed angle theorem, central angles, arcs, tangent chord theorem. Let us know what is circle. There are many objects in our life that are round in shape. A few examples are the clock, dartboard, cartwheel, ring, vehicle wheel, coins, etc. Any closed shape with all points connected at equidistance from the center forms a circle. Any point which is at equidistance from anywhere from its boundary is known as the center of the circle. Radius is a Latin word that means ray, but in the circle it is the line segment from the center of the circle to its edge. So, any line starting or ending at the center of the circle and joining anywhere on the border of the circle is known as the radius of the circle. Interior and exterior of a circle. In a flat surface, the interior of a circle is the line whose distance from the center is less than the radius. The exterior of a circle is the line in the plane whose distance from the center is larger than the radius. Terms related to circle. Chord. Any straight line segment that has both endpoints that fall on the boundary of the circle is known as chord. In Latin, it means bowstring. Diameter, any straight line segment or chord that passes through the center of the circle and its endpoints connect on the boundary of the circle is known as the diameter of the circle. So, in a circle, diameter is the longest chord possible in a circle. Arc, any smooth curve joining two points is known as arc. So, in circle, we can have two possible arcs. The bigger one is known as major arc and the smaller one is known as minor arc. Circumference, it is the length of the circle if we open and straighten it out to make a line segment. Segment and sector of the circle. A segment of the circle is the region between either of its arc and chord. It could be a major or minor segment. The sector of the circle is the area covered by an arc and two radii joining the center of the circle. It could be the major or minor sector. Angle subtended by a chord at a point. If in a circle AB is the chord and is making angle ACB at any point of the circle, then this is the angle subtended by the chord AB at point C. Likewise, angle AOB is the angle subtended by chord AB at point O. That is at the center, and angle ADB is also the angle subtended by AB at point D on the circle. Let us see the theorem. Any two equal chords of a circle subtend equal angles at the center. Here, in the circle, the two chords are given and PQ is equal to RS with the center O. So, OP is equal to OS is equal to OQ is equal to OR. All are radii of the circle. Triangle POQ congruent triangle SOR. Therefore, angle POQ is equal to angle SOR. This shows that the angles subtended by equal chords to the center are also equal. Theorem: if we draw a perpendicular from the center of a circle to any chord, then it bisects the chord. If we draw a perpendicular from the center to the chord of the circle, then it will be bisect the chord and the bisector will make at 90-degree angle to the chord. Let us see one important theorem. The line which is drawn from the center of a circle to bisect a chord must be perpendicular to the chord. Proof: if we draw a line OB from the center of the circle O to the midpoint of the chord AC, that is B. Then OB is perpendicular to the chord AB. If we join OA and OC, then in triangle OBA and triangle OBC, AB is equal to BC, B is the midpoint of AC. OA is equal to OC, both are the radii of the same circle. OB is equal to OB, same side. Hence, triangle OBA congruent triangle OBC, both are congruent by the SSS congruence rule. Angle OBA is equal to angle OBC, respective angles of congruent triangles. Angle OBA plus angle OBC is equal to angle ABC is equal 180 degree, linear pair. Angle OBC plus angle OBC is equal to 180 degree. Since angle OBA is equal to angle OBC, two into angle OBC is equal to 180 degree. Angle OBC is equal to 90 degree. Angle OBC is equal to angle OBA is equal to 90 degree. Therefore, OB is perpendicular to AC. Hence proved. Theorem. The angle subtended by an arc at the center is twice the angle subtended by the same arc at some other point on the remaining part of the circle. In the figure, angle POQ is equal to twice of angle PRQ. Let us see another theorem. Angles from a common chord that are on the same segment of a circle are always equal. If there are two angles subtended from a chord to any point on the circle which are on the same segment of the circle, then they will be equal. Angle A is equal to half of angle C by above theorem. Angle B is equal to half of angle C. Therefore, angle A is equal to angle B. Children, what is cyclic quadrilateral? If all the vertex of the quadrilateral comes in a circle, then it is said to be a cyclic quadrilateral. Theorem. Any pair of opposite angles of a cyclic quadrilateral has the sum of 180 degree. Angle A plus angle B plus angle C plus angle D is equal to 360 degree. Angle sum property of a quadrilateral. Angle A plus angle C is equal to 180 degree. Angle B plus angle D is equal to 180 degree. Points to remember. A circle is a closed shape with all points equidistant from its center. Chords are line segments with both endpoints on the circle's boundary. The perpendicular from the center of a circle to a chord bisect the chord. The angle subtended by an arc at the center is twice the angle subtended by at any other point on the circle. Opposite angles in a cyclic quadrilaterals have a sum of 180 degrees. Thanks for watching. Like, share and subscribe.